Good afternoon and welcome to another video. In the two previous videos we had explored the process of creation and traversal through a linked list, a single linked list. So now we are going to see how we can delete nodes from an existing linked list. So the basic idea of deletion is that whenever you want to delete a node, so all the nodes are connected to each other by means of links. So we are going to remove all the links that exist between this node and the previous and the subsequent nodes. So let us say in case of this illustration I want to delete the node containing 14. So to get rid of this node I will have to remove all the links to this node that exists inside the linked list. So there are two links, one with the previous node, the other with the next node. So I will have to remove these two links. Then I can get rid of this node permanently. So how we do that? First of all, we will make the previous node. So here it is 15. We will make the previous node point to the node immediately after this node. So after this node there is another node containing 12. So initially this node was pointing to the intermediate node and this node was pointing to the third node. But here, as we want to get rid of this one permanently, we will take the link of the first node and we will connect it directly to the third node. Okay, so that essentially removes all the connections between these two nodes and the second node. After we have done that, we can get rid of this node permanently. So let us now see the code and then we'll understand how it is happening. So first of all, they have created a linked list. So this is the structure of the linked list. It contains 3 elements, 10, 20, 30. Okay, now what we are doing is we are asking, so this part shows how the linked list is created. I am not showing you this part in details because it has already been discussed in the previous videos. So I'm not going to go through that all that again to so that the video does not become very lengthy. So now I'll jump straight to the part where the deletion is happening. Okay, so it will ask the user for the value that he wants to delete from the node. So if I want to delete some value from the linked list, we have to give a value that exists inside a node. Okay, so if we give a value that does not exist inside our linked list, then there will be an error situation. So first of all you will have to enter the value that we want to delete. Then we have to proceed with the deletion. Okay. So how the deletion actually happens? So first of all, before we can delete any element, we have to search for that element inside the linked list, whether that value that the user has given exists in the linked list or not. So suppose I want to delete a value 20, but 20 does not exist anywhere. So we cannot delete 20. But if I want to delete this 14, I can do that because 14 exists at the second position. So before we can delete a node, we have to search for its position inside the linked list. And for searching, we'll start from the very beginning, that is from the head, and then we will explore each and every node until we find the node that we want to delete. So first of all, it says if the head node itself holds the value. So it is possible that the head node itself contains the value that we want to delete. That also can happen. So if I want to delete the node containing 15, so it will be the first node. So what to do in that case? Let us see. If temp is not equals to null and temp data is equal to value, that means if the temp pointer is pointing to a node that contains some value and that node is the first node, that is the one pointed by the head pointer, so in that case head equals to temp next. So if the value that we want to delete, if that is at the very beginning, so that means I have to get rid of this node. So before we can do that, I have to remove all links between this node and the other nodes. So first of all I'll have to remove this link from this node to this node. So how to do that? I will erase its connection to that of the previous node. Okay. So it says head is equal to temp next. So the head pointer is currently pointing to the first node, but if we want to remove this from existence, this second node will become the head node, that is the first node. So before deletion of this, we are going to link this head pointer to the subsequent node that occurs after the first node. So the head will point to the second node right now. Okay. So head is equal to temp next. So temp is currently pointing to the first node. Temp next is actually giving the address of the next node in the series. So this one is the second node. So head is going to point to the same node which is at temp next. That is, now head, instead of pointing at the first node, it will now point to the second node. So the connection between head and this node is removed. Okay. Now it says free temp. That means once we have removed the link between the head pointer and the first node, we can remove this node permanently by using the free command. Okay. So all the memory space that was allocated for this node by using the malloc command, that will be removed and the memory will be freed up. Okay. So this is the steps. These are the steps that you have to follow if the node that we want to delete is at the beginning, that is at the head position. But it is, in most situations, the node that we want to delete, that is at some intermediate position, that is at the second, third, fourth, or any position after the head. So in those situations, what we are supposed to do? So if it is not at the head, then it will go to the else part, and it says here we are taking two pointers. Okay, previous and next. So sorry, previous and temp. So the previous pointer actually keeps track of the pointer that occurs right before the node that we want to delete. So let us say I want to delete the second node, right? So before I can delete the second node, I have to link the first node and the third node. So how will I do that? To do that, I will write previous next equals to temp next. Okay. So let us take this illustration once again. Let us say I want to delete this one. Okay. So temp is currently pointing to this one and previous is pointing to this previous node. Okay, that is 15. So the next part of this node points to this node and the next part of the second node points to the third node. So we are going to link the first node with the third node. How it is done? It is done as I have shown you. Previous next is equal to temp next. So previous was initially pointing to the second node and this node was pointing to the third node, but we want to link this one with this one. So we are writing previous next, that means the next part of this node will point to the node that is pointed to by the next pointer of the second node. So the next pointer of the second node is pointing to the third node. So now essentially this head will now get linked to the third node. So I hope you have understood this. If you have understood this, the entire process of deletion will become absolutely clear to you. So first of all, we are going to erase all the connections that exist between one node and its previous and next nodes. So for that reason, when the node is some intermediate node, we take two pointers. One pointer points to the node that we want to delete and the other pointer, which is previous, it keeps track of the node that occurs before this node. So previous will, the reason we are taking previous is that we are going to link this previous node with the node that occurs right after the node that we want to delete, and that is done using the step previous next equals to temp next. Okay, so when we are writing this step, this happens. This node now gets connected to this node. Okay, and if the node that we are looking for, if it is not found, then the value of temp will be null, because while traversing through the list, it will check each and every element until the value of the temp pointer reaches the last node. And when it reaches the last node, the value of temp will become null, and then it will stop. And if we have found the node that we want to delete, okay, if we have found the node that we want to delete, so after removing the links that exist between this node and the previous and next nodes, we can free this node, that is, we can get rid of this node on a permanent basis by using the free command. So free temp, it will now remove this node permanently from the memory. So the memory space that was allocated to this node using the malloc command, that it will be freed up and it will be made available for any other values that may want to take the place of this node. So this is the process of deletion. So I hope you've understood it. So it will be better if you can go through the code once again and practice it on your own. So if you practice it a couple of times and do a dry run of the steps, then you will understand what is going on. So that concludes my video for this particular session, and I'll see you all in my next video. Thank you.